Am I audible on YouTube? Am I audible on YouTube? Can you guys hear me on Google Meet?
Yes.
Let us have a brief class. I'm not feeling well. That antibiotic, it will not allow me to think actually. I'm just flying now. So, but I mean, I hope if I give the hint, you guys can solve problem. So, when I saw the classical mechanics questions, okay, on the CSIR net, okay, from Lagrangian mechanics part, no usual questions, okay. I mean that, like I mean, for double pendulum, write the Lagrangian, or some given some system, just like in GATE exam, they were asking uh, a different system and asking some conservation quantity. I mean, writing Lagrangian, after that observing cyclic coordinate. We don't have any of this kind of usual question, okay, in CSIR net paper, okay. But very usual questions, I mean, quite important part of the question. I mean, that is in canonical transformation, Hamiltonian, Lagrangian to Hamiltonian, Hamiltonian to Lagrangian, okay. So when I see this part, I mean, they try to grab question from very cornered concept or something, okay. So no usual question, okay, from Lagrangian part actually, okay. So two questions are there on that Hamilton's principle, okay, that action integral, okay. And then I mean, no other questions are, I mean, similar, okay. I mean, so what, that's why whenever you see this Lagrangian problem, what I feel is you should be very good at writing the equation. Given Lagrangian, quickly writing the Lagrange's equation of motion, then thinking, or solving that one, then thinking. Okay, speaker. I mean, so tomorrow I'll pick Lagrangian to Hamiltonian, Hamiltonian to Lagrangian, and after you go to Hamiltonian, how to find conservation quantity and all using Poisson bracket. So those, I mean, in those part they are asking very what you call conceptual and questions which are important. I mean, when you see the whole syllabus, so there are some important concepts. Am I right? I mean, whole when you see the whole structure of the theory, they are concentrating on that one. But as far as this Lagrangian part is concerned, okay, so questions are quite looks unusual. What I'm expecting is be quick and neat in writing the equation, okay, so that I mean you can answer, okay, write the equation, think and answer, okay, speak up. So that's why I don't think you have many repeated questions or something. So be ready for what do you call any type actually, okay, that's what I'm expecting. So see the question. The Lagrangian of a system described by three generalized coordinate. Okay. So Q1, Q2, and Q3. He has given this Lagrangian. Speak up. So then where small m, capital M, K are positive constant. Okay. Lagrangian is half m q dot square, q1 dot square, q2 dot square. q3 dot square is not there. Okay. So m q1 dot q2 dot. K q1 dot q3. Okay, speak up. Q3 dot is not there. Okay, see this one. So now he's asking two coordinate remain constant and one evolves linearly. Linearly means with respect to time. Evolves means with respect to time only. Okay, so one coordinate remains constant, one evolves linearly, like that. Okay, now I mean, by just seeing the Lagrangian, you can't answer any of these. You have to solve Lagrange's equation of motion. Okay, let me write the Lagrangian again. So what is this one? Half m q1 dot square plus q2 dot square, then plus capital M q1 dot q2 dot plus capital M q1 dot q2 dot, fine, plus k q1 dot q3 plus k q1 dot q3, fine, speak up. So corresponds to q1, generalized coordinate q1. Okay, what is the equation? D by dt of dou L by q1 dot dou L by dou q1 dot minus dou L by dou q1 equal to 0. Write the equation. Speak up. d by dt of dou L by dou q1 dot m q1 dot, okay, not over here, also you have q1 dot plus capital M Q2 dot. I'm doing quite slowly. You guys have to do bit faster. Not over, am I right? You have Q1 dot here also. What is that? Plus K Q3. K Q3 equal, I mean, minus dou L by dou Q1. There is no Q1, okay? Speak up. So that's why that's equal to 0. So this is the equation, okay? Corresponds to Q2. D by dt of dou L by dou Q2 dot minus dou L by dou Q2 equal to 0. What is this one? D by dt of, okay, M Q2 dot, fine, plus capital M Q1 dot. Now look at it. You can't quickly solve this one. Okay, write all three. Okay, think over it. I mean, questions. I mean, many questions are like that. I mean, there is no one method. Okay, speak up. You have to write. You should be very good at writing the equation. That's what I'm expecting. What is this one? Q2 dot. Am I right? There is no Q2 dot. Yeah. So this is equal to 0. Speak up. I mean, here you can say that this whole thing is constant with respect to time. I mean, you can't talk about individual coordinate, okay? So see the last equation, Q3. D by dt of dou L by dou Q3 dot minus dou L by dou Q3 equal to 0. Dou L by dou Q3 dot, you don't have Q3 dot at all. Okay? So dou L by minus dou L by dou Q3 equal to 0. What is this one? Minus K Q1 dot equal to 0. You start from here. Okay, what is this one? Q1 dot is equal to Q1 dot equal to 0. Q1 is equal to constant. Isn't it? Constant with respect to time. Okay, you go to this one. If Q1 is constant with respect to time, let me do here only. Okay, how simple it is. If you write equation neatly, when you substitute here, okay, Q1 dot is 0, what you get? D by dt of, okay, M Q2 dot equal to 0. What do you mean by this one? Q2 dot is constant. Am I right? Q2 dot is constant. Q2 dot is equal to constant. I'll write this is C1. I'll write C2. What is Q2 dot? Q2, that is C2 into T plus some other constant like that. I mean, linearly. You got my point. Just substitute. I mean, Q1 dot is 0. I'll substitute here. I observe that this is 0. That means Q2 dot. Okay, its time derivative is 0 means Q2 dot is constant. Okay, its time derivative is constant means that varying linearly, isn't it? Now substitute these two into first equation. Substitute these two into first equation. Okay, so what you have? Q3. This first equation will look at here. You know what is Q1, what is Q2. First equation will get you what is Q3, isn't it? What is this one? Q2 dot is a constant. Okay, what is here? Q1 dot is 0. Okay, so that's why this equation gives you d by dt of, okay, so Q1 dot is 0, Q2 dot is constant. Okay, constant plus K constant, M Q2 dot, am I right? M into C2 if I write accurately. Okay, plus K Q3 equal to 0. What do you mean by this one? Again, if you integrate this one, what would you get? So this constant time derivative is 0. Q3 time derivative is 0 means it is constant. Q3 is equal to constant. I'll write C3. Okay, just observe these things, collect these things. Okay, Q2 is varying linearly. Q1 and Q2 are constants. Fine. So that's what I told. There is, suppose if you look for how many questions they asked similar type, no other questions like that. Okay, speak up. So what you should be good at? You should be good at writing the equation. That's it, neatly. Okay, and then thinking. Okay, speak up. Two coordinate remain constant. One coordinate evolves linearly. Fine. Speak up. Very simple. So do this one. So I hope this one you can do. It's not a big deal. Okay. So equation of motion of the system, Lagrangian is given. Okay. So e power gamma t. Okay. Speak up. Half m x dot square. Okay. Minus v of x. I think in Goldstein, he might have given similar problem and asked us to transform or something somewhere. Okay. Can you just grab this one? It's reflecting onto you. No, this one. Yeah. Speak up. It's reflecting too much. No. That whole chair. Wait a second. Wait a second. Hold on. Sorry. Dust. Careful. Yeah, leave it. I mean, anyway, this problem is not any difficult. I mean, what I recall is when I see this question in Ghostin, he started with this one. He gave us some transformation or something. Okay, that's what I recall. Okay, so now just write the equation and you will get the option. Okay, speak up. What is this one? D by dt of dou L by dou x dot minus dou L by dou x equal to 0. Find what is this one? D by dt of dou L by dou x dot e power gamma t e mx dot. Fine. Minus one more negative sign plus dou v by e power. Don't forget e power gamma t. Okay. E power gamma t into dou v by dou x equal to 0. If you take time derivative, you will get the option. Okay, this e power gamma t is common. Okay, you can cancel it out. Right hand side is 0. Okay, speak up. E power gamma t e m x double dot. Okay, speak up. Gamma e power gamma t e m x dot. Fine. Plus e power gamma t. Okay. So since v is a function of only one variable, I can write as dv by dx. Okay, equal to 0. Okay. E power gamma t can take common, the right hand side is 0. Okay. I mean, e power gamma t cannot be 0. Okay. So that's why the rest of the parts are 0 once you take it common. Okay. That's how we can argue. What is this one? Emx double dot plus gamma emx dot plus dv by dx equal to 0. Fine. Minus. So in the Lagrange's equation, one negative sign comes, okay? And here also one negative sign is there, okay? Fine. Check this up. Option 1. Yeah. So like that, look into this question. Again, you should be good at writing the equation, that's it, okay? Lagrangian of a particle moving in a plane is given in the Cartesian coordinate, okay? In polar coordinate, the expression for canonical momentum, okay? Speak up. So, I mean, you already know the transformation equation, am I right? X equal to r cos theta, okay? Y is equal to r sin theta, am I right? Speak up. So, x square plus y square is equal to r square, am I right? Because here you can write negative sign taken outside, direct one r square comes, okay? X square plus y square is nothing but r square, okay? So that's quite easy. But x dot y dot should be worked out. Okay, speak up. What is x dot? Think both r and theta are variable. Okay, speak up. That's equal to r dot cos theta minus r sin theta theta dot. Okay, y dot is equal to r dot sin theta plus r cos theta theta dot. Okay, Speak up. Now what is this one? Now you rewrite the Lagrangian. Lagrangian is equal to x dot into y dot. R dot cos theta minus r sin theta theta dot, okay, multiplied with r dot sin theta, r dot sin theta plus r cos theta theta dot, okay, minus simply r square. Am I right? If you take negative sign outside, okay, you can write like this, x square plus y square is r square. Now what is asking? Should we multiply? I mean, what is PR? Dou L by dou R dot. Am I right? Speak up. We better to multiply it, isn't it? Better to multiply it. Okay. So what is this one? R dot cos theta, R dot sin theta, R dot square. So cos theta into sin theta. Okay. So plus R dot cos theta into R cos theta theta dot minus R sin theta theta dot R dot sin theta. Okay. So I don't need rest of the term. I mean, other term contain theta dot. Okay. I need terms which have only R dot, isn't it? So when you see this one, so PR, that's equal to dou L by dou R dot. Am I right? Is that right? Speak up. That's equal to, so 2R dot, okay, cos theta into sin theta. Okay, that is this part. Okay. Here I can take R dot common here. I will write the rest of the part. Okay, R dot here, R dot here. Okay. If I take R dot common, the rest of the part is, okay, R cos square theta minus cos square theta theta dot. R theta dot also can be taken common. Am I right? Look at here. R theta dot. R theta dot. Fine. If I take r theta dot common, actually r dot also common, that partial derivative is 1. Okay, I'm writing quite directly. Okay, you write in your way. Okay, speak up. R theta dot, okay, I'll get cos square theta minus sin square theta. This cos square theta minus sin square theta can be written as cos 2 theta. Am I right? What is this one? I mean, 2 cos theta into sin theta is sin 2 theta. Okay, so plus r theta dot. What is this one? Cos 2 theta, nothing. You have options. R dot sin 2 theta, R theta dot cos 2 theta. So when I see this one, I mean, nothing much concept, these things are involved. Okay, speak up. Like, I mean, we learn to, I mean, go for generalized coordinate, writing the equation in general, not like that. Okay, very equation, working on equation. Okay, be good at writing the equations neatly. Okay, speak up. Fine. This also. The dynamics of a particle is governed by Lagrangian. Okay, speak up. It is an undamped oscillator, damped oscillator with varying damping factor, undamped oscillator with a independent time dependent frequency, free particle. Okay, speak up. I mean, just by looking into Lagrangian, how do you say Lagrangian contains time means? Can you say it is a non-conserved system like that? Non-conservative? No, you can't judge like that. Okay, because Lagrangian can differ by some total time derivative or something. Lagrangian is not unique. Okay, in Ghostin we have studied on theorem. Am I right? So that's why don't judge just by looking into that one, like it have time or something. Okay, write the equation. So because when you see first three option, okay, so damped, undamped, harmonic oscillator, how do you judge? By seeing the differential equation actually, isn't it? So that's why So you just write the Lagrange's equation of motion. It will turn out to be free particle. Speak up. I think we did in class. Am I right? D by dt of dou L by, I'll just dou x dot minus dou L by dou x equal to 0. What is this one? D by dt of mx dot okay, what is this one? Minus kx into t, fine, minus dou L by dou x, okay, that will be plus minus one more negative sign kx, isn't it, plus what is this one? K x dot into t equal to 0. Fine. So just take this one, okay, take time derivative here, mx double dot minus kx dot t minus kx plus kx dot t equal to 0. What you ended up with? Mx double dot equal to 0. That means it's a free particle. Acceleration is 0, isn't it? That means x dot is equal to constant. It's a free particle. I don't know whether you can judge or not. I mean, this differs from free particle Lagrangian by one total time derivative of some function. I mean, if you can judge that one, that's good actually. But I mean, writing equation, I hope that's what I see. Okay, when I see all CSIR net question, be good at writing equation and think. Okay, on this part, fine. One more here, action. What's that? Action integral. Okay, action integral means integration of L dt. Am I right? I mean, we wrote it as S or something. So from time, can I say t1 to t2? Okay, L dt, Lagrangian into dt. Am I right? Speak up. That's it. The motion of a particle in one dimension is described by the Lagrangian. Okay, so in a suitable unit, okay, see the Lagrangian. Okay, that's equal to half x dot square minus half x square. Okay, when you see this one, what do you see? I mean, what system it is? Can you quickly judge? Harmonic oscillator. I mean, kinetic energy, potential energy. Maybe K is taken as unity. When he said in suitable unit, mass is taken as unity. Fine. Speak up. So then, I mean, what you need is here. Okay, if you want to find this action integral, L should be written in terms of time, isn't it? So then, I mean, if you want to write L in terms of time, then I mean, you should know what is x as a function of time. I mean, so if you want to do it, I mean, in ideal way, okay, d by dt of dou L by dou x dot minus dou L by dou x equal to 0. Okay, what is this one? D by dt of x dot plus x equal to 0. What is this one? D square x by dt square plus x equal to 0. Am I right? Speak up. D square x by dt square plus omega square x equal to 0. Am I right? What is its solution? X of t. Most general solution A sin t plus B cos t. Omega equal to 1. B cos t. Can I write like this? So now he gave some initial condition also. I mean, if you wish to proceed with whatever he has given, okay, at t equal to 0, it is at x naught. Am I right? at t, sorry, what happened? Classical path from x equal to 0 at, sorry, x equal to 0 at t equal to 0. Am I right? Speak up. X equal to 0 at x of 0 is equal to 0. Fine. So that's why b should be 0. Isn't it? That implies, okay, speak up, 0 is equal to 0 plus b into 1. Am I right? B equal to 0. Isn't it? So that means your solution is sine function x of t that's equal to a sine t. Okay. I mean, okay, how do you find a now? At t naught, you have x naught. Am I right? Speak up. X at t naught is equal to x naught. Okay. So that's equal to x naught is equal to a sine t naught. A is equal to x naught by sine t naught. And now I'll not use this one in the equation. I will substitute this one later. Okay. A value, I'll substitute it later. Fine. I'll keep it here. I'll use a only, symbol a only. Fine. Then what I have to do? Lagrangian. Okay. Lagrangian is equal to half x dot square. What is x here now? X of t is equal to a sine t. Okay. Speak up. X dot is equal to a cos t, isn't it? So Lagrangian in terms of time, a I will substitute later. Okay. Speak up. L is equal to half x dot square half a square cos square t minus half x square half a square sine square t. Okay. So half a square you can take common, isn't it? What is this one? Half a square. Again, cos square t minus sine square t. What is this one? Cos 2t. Okay. So now you need to, that action integral, okay, t equal to 0 to what he said? T naught. Am I right? T equal to 0 at x equal to 0. Okay. X equal to x naught at t equal to t naught. T equal to 0 to t naught. Okay. Speak up. What is this one? So half a square cosine of 2t, this is Lagrangian, into dt. Okay, what do you write? What is cos 2t integral? Sine 2t by 2, integral running from 0 to t naught. Lower limit it is 0. That's equal to 1/4 of a square sine 2t naught. Fine. Now substitute a square. Okay. So 1/4 of, okay, a square is x naught square divided by sine square t naught. Expand this sine 2t naught. What is this one? 2 sine t naught into cos t naught. Speak up. 2 on the 2 the one of the sine got cancelled. Okay. X naught square by 2 into cot t naught, isn't it? X naught square by 2 x naught square by 2 cot t naught. You have only one option. Fine. So again, when I see this question, it looks writing equation. Am I right? So nothing much to think here. Okay, speak up. Now I will take this question. Okay, so which is quite different. Okay, so there is one more question here. You guys try that out. Which of the following term, when added to Lagrangian of a system, okay, with 2 degrees of freedom, will not change equation of motion? Now, none of these are total time derivative of some function, isn't it? Then that theorem is ruled out. Then how do you do? I'll say L dash is equal to L plus this quantity in the option. In the option, are you getting my point? It should not change the equation of motion. Okay, that means if you do this one d by dt of dou L dash by dou x dot minus dou L dash by dou x equal to 0. Okay, when you substitute this one, what would you get? D by dt of dou L dou I'll write dou L by dou x dot, okay, minus dou L by dou x plus d by dt of dou by dou x dot of this one, this quantity, isn't it? I mean here, so L plus this one, that part I will separate it. I mean derivative, it's a linear operation. Am I right? Speak up. So minus, okay, what is this one? Minus dou by dou x of, speak up, that quantity equal to 0. Are you getting my point? That means that quantity should satisfy Lagrange's equation of motion. Okay? I mean, if you take that quantity as I mean, if you place it here in the Lagrange's equation, I mean, it should be 0. It should give 0. Am I right? If this quantity is 0, then old Lagrange's equation of motion is same as new Lagrange's equation of motion. Is that okay? Start substituting the option. Okay, fine. Are you getting my point? I mean, somehow, if these two are to be equal, this part must be 0. What is this one? D by dt of dou by dou x dot minus dou by dou x equal to 0. Fine. And you need to do that one for both coordinate, not only one coordinate. Fine. Both coordinate, because you have two degree of freedom. Am I right? Speak up. Can you guess? I think 3 and 4 must be ruled out. Can you tell me why? And I think if you substitute here, okay, x dot derivative, x dot derivative is minus y, okay, plus x derivative is y dot. So check that out, okay. Substitute each and every option. Start from option A only, okay. Check which one, what you call, satisfies that one, okay. Speak. Again, this also what is again writing the equations, okay. Speak up. So now what I wish to explain this particular problem, okay. Speak up. Relativistic Lagrangian. I think for new students, I mean, we need to discuss this one, okay. I think I didn't discuss relativistic Lagrangian or Hamiltonian, okay. After special theory of relativity, we shall discuss, okay. Those who are doing revision, they can do this one, okay. So you should know that, okay. He said free relativistic particle. I mean, you don't have to think much. But I mean, finding relativistic Lagrangian may be one of the problem. Is that okay? Speak up. How do you start here is, okay. So you write your canonical momentum is equal to dou L by dou x dot. Am I right? Speak up. So now what I'm going to do here is, I mean, this P relativistically, what is this one? M naught V divided by root of 1 minus V square by C square. Relativistic momentum. Okay. So now what we do is, okay, we substitute this one, M naught V by root of 1 minus V square by C square. What is this one? This is P. That's equal to, I will write this one as, what is this one? Dou L by dou V. I mean, I'll take one dimensional motion. Only x dot is coming. Okay. Now this equation you need to variable separate. I mean, variable you need to separate, and you need to solve for Lagrangian. Okay. Speak up. When you do this one, okay. So dl, that's equal to m naught v by root of 1 minus v square by c square into dv. You need to integrate it out. Can you do it? Then you will get this one. How do you integrate this one? Substitute 1 minus v square by c square as some t. Then 2v dv will be dt. Okay. So when you do this one, you will end up with this kind of Lagrangian. What he wrote? Speak up. I think he didn't take c here. I think c should come. Velocity of light. Okay. C he might have taken 1 over there. Okay. What is this one? Yeah, minus m into root of 1 minus x dot square. Okay. Fine. Yeah, that's it. I mean, I just want to just go around that question. Okay. Speak up. I mean, if you see other question, you can't go around that question. Okay. Only those questions, separate questions. Okay. Speak up. So you do this one. Okay. You find L, I mean, minus, I think, something m c square or something. Okay. So check this out. Okay. Root of something will come. Okay. Plus some integration constant. You don't have to worry. Lagrangian, if it contain any constant, equation of motion will not contain that constant. Am I right? Speak up. So you do this one. Okay. Because that may be separate question, I guess. Okay. What is this one? Finding relativistic Lagrangian. I mean, so until now, how did we write Lagrangian? I mean, just kinetic energy like that. No, this won't work like that. Lagrangian, okay, it's not a physical quantity. Okay, you can't think like that. When you see this one, okay, this is a Lagrangian for a free relativistic particle. How do you understand this one? Isn't it? It's not. I mean, is that half mv square? No. That's why it should be started with this what you call equation, because this is very fundamental equation. Okay, canonical conjugate definition. Okay, speak up. So I mean, maybe in modern textbook we might have started the whole discussion in a different way. Maybe it might have evolved like that. Okay, from canonical idea. Okay, who knows? So that's why. Okay, that's it. Okay, I mean, I was talking about relativistic Lagrangian. Now, what he's asking, if such a particle is acted upon by a constant force, okay, F is equal to F naught, in the direction of its motion, then phase space trajectory obtained from corresponding Hamiltonian. Whenever phase space trajectory comes, you should go for Hamiltonian, isn't it? Speak up. So now, if force equal to constant, what is the potential? Can you guess? F should be equal to minus dV by dx. Am I right? Speak up. Then v of x, that's equal to minus f naught into x. When you take negative derivative, you are getting f naught. Fine. Now you should know that, I think from relativity, you know this equation, E square is equal to p square c square plus m naught square c power 4, energy and momentum related expression. Okay. So now for free relativistic particle, we write Hamiltonian simply root of, actually again you can start with this Lagrangian, you can transform to Hamiltonian, Lagrangian to Hamiltonian. But I'm expecting you should not do that one. Okay. If you remember this equation from relativity, okay, what is E here? Root of p square c square plus m naught square c power 4. I'll take that one as my Hamiltonian for free particle. Okay, what is this one? P square c square plus m naught square c power 4. Speak up. But that is, this part is for free relativistic particle, Hamiltonian for free relativistic particle, but it is acted upon by constant force minus some f naught into x. Fine. I mean, I just added v of x part. Okay, plus v of x part. That's what I'm writing here. Is that okay? Here also, I mean, so did you solve this one? What will minus m c square will come? root of 1 minus v square by c square will come, I think. Am I right? Plus some constant if you wish, isn't it? Now look into this. Look into this one. This is the Lagrangian for a free particle. If you want to write Lagrangian for a particle under any force or something, what you have to write? Root of 1 minus v square by c square plus v of x. Not plus. What is this one? Minus v of x. That's it. This is for free particle. If you want to apply any potential, okay, you have to rewrite it like this. So similarly, so this is the, this portion is for free relativistic particle Hamiltonian. You have potential, you just add that one. Fine. While transforming Lagrangian to Hamiltonian also, this part will just change the sign. Am I right? Speak up like that. Grab some idea. Okay. So now, so when you, now if it is conserved, if energy is conserved, okay, speak up. Just see this one. What will happen? Root of p square c square plus m naught square c power 4 plus v of x. Okay, that's, I'll write it as some e naught. Fine. Speak up. Then now, you are okay. What is v of x? Sorry, minus f naught into x. Now you try to rewrite this equation. What will happen? P square c square plus m naught square c power 4. That's equal to, can I write e naught plus f naught x. The whole square. Fine. The whole square. Okay. So e naught, or f naught, or I'll do f naught x plus e naught the whole square. Okay. Minus p square c square. That's it. I'll take this p square c square to the right hand side. That's equal to m naught square c power 4. What is your hyperbolic equation? F, if you take this f naught square outside, okay, what you will have? X plus e naught by f naught the whole square divided by m naught square c power 4 minus p square c square by m naught square c power 4 is equal to 1. What is this one? Hyperbolic equation between x, shifted hyperbola between x and p. Is that okay? Speak up. Hyperbola. Or at least when you land on this equation, you should be able to judge. It's not parabola, not ellipse, okay, not cycloid. So cycloid equation comes somewhere, okay, in that electrodynamics problem somewhere, okay. Speak up. Fine. Hyperbolic equation, you take it here. Shifted hyperbola. Can you see that one? Hmm.
Can't we do this by drawing potential graph?
No, that potential graph, okay, that's a very good idea. But this, how do you write this one?
F naught is constant. Minus x.
You can quickly get to know that it is not any closed curve.
It should be hyperbola.
Yeah, that's a good idea. You can just eliminate these two options quickly, isn't it? It will be unbound motion. When it is unbound motion, it cannot be ellipse. Okay, speak up. Parabola, how do you eliminate? You may get some curve or something, okay, but what is that actual function? That I think you need to work out the equation. Okay, so in other phase-based trajectory question in CSIR net, very repeated question, they gave 4 phase-based trajectory. In that case, you can go to potential and do that one. Okay, I think this is what they're expecting here in this problem. Okay, so relativistic Lagrangian, relativistic Hamiltonian. Okay, speak up. Fine. Let us close it here. So tomorrow, what I will do is I'll pick central force problem. Because I found lots of question in all exam, including CSIR net. Okay, I mean last two paper also I analyzed. Okay, they asked one or two central force problem question. Okay, speak up. I mean central force actually, I mean they can design varieties of questions. Okay, I mean that's what I felt. Okay, you try rest of the problem. Okay, I may take one or two of these problem. Okay, whatever I have posted, and then I will go to central force problem. Okay, speak up. Wait a second, I'll keep rest of all questions here in the slide. I think this is one of the question where you can handle in a cylindrical coordinate actually. Okay, we did this similar problem. Speak up. Whenever you see x square plus y square equal to az, that's a constant equation which can eliminate coordinate in the cylindrical coordinate. You should quickly judge that one. Am I right? Why? In the cylindrical coordinate, rho square is equal to x square plus y square. Isn't that means rho and z are related? Okay, speak up. So when I see the question again, keep on writing the equation. Look at here. So they gave one Cartesian coordinate harmonic oscillator in the Cartesian coordinate. You need to transform. I mean, neatly writing the equation only again. Okay, speak up. Yeah. So that's why solve this problem neatly. Okay. I mean, if you stuck, I'll again pick up that problem tomorrow. Solve this problem neatly and quickly go for revising central force problem. Okay, speak up. So then after that, day after tomorrow, we'll pick Hamiltonian. Okay, then we'll spend one day on canonical transformation. I felt that question is quite frequent and quite easy to execute. Okay, in the exam. Okay, speak up. Fine. Yeah, any question on Google Meet? Okay, we'll meet tomorrow.